Good morning, everybody, and welcome to this UKSTT trenchless tea break. It's just 11 o'clock now. We will wait a couple more minutes for some more people to join, and then we will get started. Good morning, everybody. We've gone a few minutes past 11 to allow everybody to get logged in, so we will start. Welcome to this UKSTT trenchless tea break on the topic of transferring minimal excavation methods. My name is Tom Sangster. I'm from Downley Consultants, consulting engineer. I'm also chairman of the Technical and Education Subcommittee of the UKSTT, and I'll be your host and moderator today. We have three very well-known, very experienced and very eminent speakers to talk on this subject who've been involved with the Acquia project. Joe Parker is a chartered civil engineer, very well known to many people in this industry. On the little biog she sent me, there must be a misprint because it says how many years she's worked in the water industry, and she's far too young for that, but certainly many years. And Joe's held a variety of roles with various UK water companies. Joe's currently working as an independent consultant, specialising in the management of water mains, and she is recognised internationally as an expert in this field. She has particular expertise in location of water mains and other buried assets, and also in applying the principles of asset management to developing countries. Joe, for the first presentation, will be working in conjunction or presenting in conjunction with Dr. Leo Carswell. And Leo is a principal consultant in technology and innovation at WRC and leads the whole technology business area at WRC. Leo is passionate about the role new technology has in industry to enable change. And in this role, Leo is responsible for WRC's activities in the development, assessment and implementation of a wide range of technology within the water, waste and environmental sectors. This includes the WRC approved fitness for purpose scheme, and also leading WRC's activities in Scotland on the Hydro Nation Water Innovation Service. Leo led WRC's technical delivery of the recent Acquia project on transferring minimal excavations to the water sector, which is the topic of today's tea break. And he's worked with the gas sector for many years on the transfer of CIPP technologies from water to gas applications. Leo has a PhD in instrumentation for water quality monitoring, together with over 20 years of wide-ranging experience gained while working at WRC. Leo and Joe will be followed by Jeremy Heath, who is Innovation Manager at SES Water, With over 25 years experience in the water industry and a background in both mechanical engineering and database applications, Jeremy is responsible for the management of innovation within SES Water. This involves both the development of an innovation culture and the introduction of new technologies into the water industry. He has a keen interest in innovations that will transform how we manage our water networks, in particular smart metering, smart networks, artificial intelligence, and Internet of Things communications. In addition to his role at SES Water, Jeremy is also the lead for the Acquia National Zero Leakage Project and is responsible for driving the whole UK leakage research programme. So they will have a lot that's very interesting to tell us about this whole Acquia project and minimal excavation methods. A little bit of housekeeping. We will run through the presentations and then have a Q&A discussion section at the end rather than after each presentation. Feel free to use the Q&A function, which you'll find on your screen if you wiggle your cursor about, to ask any questions, and we'll store them all up there, and then we'll get them discussed and answered at the end of the webinar. The webinar is being recorded and will be available to view on the UK USTT YouTube channel shortly. You can find that and a lot of other things on the UKSTT website, www.ukstt.org.uk. Lots of technical resources, a lot of technical information all about trenchless technology is there to help you. So that's all from me. I'll leave Leo to take over the screen and start with the first presentation. Leo.
Thank you, Tom. Good. You should see the title presentation slide.
Yep.
Good. Thank you. So I will hand over to Joe in a minute, but just to introduce this project, Tom's really given a very good introduction, but between myself and Joe Parker, we're going to talk through a recent Acquia project that we've been delivering, working very closely together. So Joe, I'll let you give the starting introduction.
Great, thank you very much. And I would say that this particular project was very close to my heart because in my role, for instance, with Affinity as head of network asset management, I went to a number of leakage conferences and I could never understand why an important part of leakage management was never covered at these conferences. Repairs are absolutely essential when managing leakage. It actually comprises the majority of the cost of eliminating a leak. Exactly what percentage of the cost of removing a leak depends on the cost of the leakage detection as well as the leak repair, but it's usually in the order of 3/4 of the cost. It causes a huge amount of disruption, apart from the impact on traffic. There may be loss of access to properties, and of course it has a huge impact on carbon footprint. And the water industry is looking to be carbon neutral in their operations by 2030. So reducing carbon for repairs is really important. And because water mains tend to be below other services, there is always the potential to damage other services in excavation. Of course, the other big thing is it's the public face of a water company in a lot of cases. It may be the only time that customers are aware that there is a water company working out there. And the roadworks notices usually these days inform what company is doing the work. So ensuring that looks as efficient and as up to date as possible is really important. I know Jez is keen on saying we still repair leaks in the same way that the Romans did, which is actually very true. And this project doesn't just apply to the Acquia zero leakage by 2050. It also has an impact on another Acquia project that's looking to achieve zero interruptions to supply, because if a repair requires cutting out a main, then there will need to be an interruption in the water supply, at least for a number of customers. And we are aware that the minimum dig techniques are used more widely in the gas industry, as Leo has touched on. So this project was looking at what is being done elsewhere and how these techniques can be transferred. And you may wonder why I've got a picture of some sort of opera singer on the right, but in the saying, it ain't over till the fat lady sings. And in my view, a leak is not finished until it's repaired. So repairing a leak, in my view, is the equivalent of the fat lady singing. With that, I shall hand over to Leo to talk about the actual project, and I'll be finishing off a bit later.
Right, thanks, Joe. Let me move through these slides. So, yes, that's a great scene setting. So I've got some slides to talk through and provide a bit of an overview of the work that we've done this project. Probably important to say the output from this work the report is being made available widely. So where we have a slide on a certain topic, actually you will be able to gain access to the report and all the details. So that's I think that's an important thing to say, because there's a lot more detail to this project than we can possibly cover in this hour. But hopefully we can provide a good overview to the project. So as a good starting point, really this project was really about identifying potential technologies and processes that could be transferred to the water sector from other sectors, and looking at how those might be used to solve the challenges that Joe's just talked about. And that's everything from pre-excavation, before you even dig the hole, through to the reinstatement, so the whole process. And this project, I think it was quite unique in terms of the way Acquia operate, in that we had a partner on the project in SGN, Scotia Gas Networks, who were very active in the project. So we were, rather than just engaging through contacts in the gas industry, we actually had the gas industry sitting as part of the project. A guy called Ollie Machin, who's the innovation manager at SGN, was really able to tell us the reality of what the gas industry are doing, maybe rather than just maybe what we hear through press releases. So as Joe's talked about, she project managers, and the WRC team was not just me, there were other people. So Dr. Andy Russell, some of you may know from his work, Joe Hewlanson and a few other people. So, and we had quite a big steering group from the water companies. So these projects are run with input from a group of water companies who steer and direct the project as we go. And that's essential, really, that we make sure that as we progress through this work, it's delivering what the industry needs, not just what maybe WRC think or Joe think we need to deliver. So anyway, I'm going to cover four things in the next few slides. I'm going to talk a bit about the technologies and processes related to minimal excavation and what we found and what our thoughts were. Talk a bit about some of the challenges, because this is not without challenges, this area. It's really probably the reason why this project is here, is because there are significant challenges to overcome. I'm going to talk a little bit about how the supply chain, how we can support the supply chain and help them in terms of developing solutions and implementing solutions, because that's a key aspect. And then the final thing I'm going to do before I hand over to Joe is really talk a little bit about where next, because really this is a project which is setting out the foundations as to the challenges and the opportunities and potential ways forward. But the reason why me and Joe are talking about this here at No Dig Live and abroad is because there's much more to do in this area. There's many more projects. And one of the key messages from today is if you want to get involved and engaged, please get in contact, because we need partners and we need people who can support this work going forward. So that's something to take away. So I've probably got 15 minutes of slides, which I will talk through now. So where we started, and it's probably a good starting point, is really looking at a bit of a vision for the future. This project was about looking at the future. It wasn't about looking at the past, not about how we repair or how we dig holes. We know how we do that at the minute. It was really setting a vision for the future and what excavation leak repair might look like in the future. And that is a different water industry. I think we have to accept that. Doing business as usual in a different way, and looking at the opportunities, but addressing some of those challenges. And that's what this project was really all about. So let me show. So we started this project by setting out 3 visions for the future, and they are an evolution of the ways of working, and they cover, as I've said before, the aspects from even before you get on site through to the activity of excavation or not excavation, and through to installment and repair and etc. And we have these cartoon type diagrams which really illustrate that, and I think we found these work quite well in terms of engaging with people. A key thing to say here really is we're talking no dig here, but actually, and I'll talk about each of these in turn in a minute, the majority of this is about minimal excavation, smaller digs, and that is probably part of that evolution of moving to no dig, is how you dig smaller and you dig more effectively and more efficiently. So we'll talk about the first one. So this is our first scenario, and this is a sort of evolution of current approaches, and it's about benefiting from technologies that are in existence, but maybe aren't used as widely as they could be. And there's 3 aspects here that we talk about in this scenario. The first is around accurate pipe detection and technologies to be able to locate the pipe and the leak accurately enough to enable other technologies, and that's, we'll talk about that in a minute, but that's one of the key stepping stones really into enabling some of the later technology. And there are technologies available that can do that, but it's not business as usual. The middle diagram with the character with his long stick is about use of tooling which enables operators, engineers, people on site to be able to fix pipes without actually needing to be in a pit. So operating from above ground using long handled tooling in this case. This is something the gas industry has developed and does use to a certain extent. The water industry has started to look at this, but it really isn't, it's very early days. But that it potentially enables both health and safety improvements, but also it enables the use of smaller excavations, because you don't need to put someone in. And on the right hand side, we've got technologies which are well known to people now, coring technologies and vacuum excavation technologies, which are currently seen by the industry as very expensive. They're probably quite bespoke in terms of their applications, but actually trying to change that and move that to business as usual and identifying how those technologies can be identified is something that has to happen. There's also some other aspects around backfill type materials. So this is relatively close to what we could achieve. This is definitely not looking too far ahead. The next one is taking that further vision of the future, and this is based primarily on what the gas industry is doing, and specifically SGN working with ULC Robotics, a company based out of New York, developing robots for doing roadworks, and that's what this central picture is. And they've developed a system which does the end-to-end process from scanning the ground, locating the pipe, through to excavation, repair and reinstatement. And it's heavily funded by Ofgem innovation funding, but it's really a big demonstration project of potentially what is possible, what the gas industry could achieve. And the reason And I think it's important to set out the reason why the gas industry have actually done that. It is twofold. It's not just about inner city excavations and road closures and minimal disruption. It's also about a long-term vision that the industry shouldn't be employing people based on their physical ability to dig holes. The gas industry has made that statement that actually in 25 years' time or whatever, we don't want to be employing people. We want to be employing people to operate robots and use their minds in clever ways, not to dig holes with spades. And that's quite a visionary thought, I think, in terms of health and safety. So there's a whole range of technologies here. This is quite futuristic for the water industry. I think a key thing to say, and a number of us, Jeremy was there as well, we went at the end of April to a demonstration day looking at this technology. And it was interesting to see the technology operating, definitely. It was also interesting to talk to the guys at SGN and ULC and understand how they've developed this system, really advanced, very expensive system. But actually what they're thinking about now is how they essentially almost deconstruct that system and use different components for different applications. Maybe the ground scanning identification of the pipe is used in some applications, but not all. Maybe the vacuum excavation or the chainsaw, which cuts whatever shape you want out of the road surface, is used in some applications, but not all. Because actually the niche for a very expensive robot system is quite unique, really, probably an inner city application. And actually the potential is much, much wider. Anyway, that's the second scenario, aspiration. And the third one is the no dig aspiration. And this is the one that we actually didn't focus so much in this project on this. This is saying, what can we do, what technology is available where we don't need to dig a hole. We have in-pipe robotics, which are detecting leaks and repairing leaks, or we have systems and processes for lining and repairing water mains, which negates the need for traditional external repair type technologies. And I know, I'm sure there are people on the call who have expertise in some of these technologies. We are seeing the transfer from the wastewater sector of things like SIP and other repair technologies. A lot of this is very academic, definitely on the left-hand side. The robotics is still in an academic arena, but as a long-term vision, I think it's where the industry would like to move. So you're probably thinking this all sounds great, Leo, but there's about 1 million reasons why half the stuff you've shown on the screen isn't going to be possible and doesn't happen in a minute. And I think that was a key thing for this project. It wasn't just about doing a really good look at what exciting technologies are out there and saying, water industry, you should be doing this, why aren't you? It was about identifying and understanding the reasons why and trying to unpick some of those blockers and help the industry move forward. So in that light, we had a workshop as part of the project, and we invited people from supply chain, water companies, consultants, contractors. We opened it up to anyone who was interested and felt they could contribute to this. And we presented these scenarios and using this was all during lockdown, so using Myroboard, we captured people's views around the challenges and the blockers, and we tried to do this in a very structured way. Very easy for people to say, well, it's all just too expensive or it's too difficult. Tried to capture this in a way around things such as the technical barriers, financial barriers, the barriers around people, process, and then some around the regulation. So through quite a structured process of identifying these barriers and capturing them and looking at them in detail and critiquing them and actually trying to understand what it really meant for the industry. So that's the process we followed. And I just wanted to highlight, there's a lot more in the report, but I just wanted to highlight some of these potential blockers or barriers. And I don't think people on the call will be surprised by a lot of these. These are the same that you may expect for a lot of water industry things. So if we look at things such as, even before you do the excavation, what are people saying are the potential losses? Well, there is always this issue in the water industry around it's a low value product and there isn't the money there. So compared with gas or oil, it's always cited as a potential challenge. There are some more specific things around the lack of technology skilled operatives. If we're moving to a more technology focused approach, then that's definitely something. And then the engagement with stakeholders on equipment, that's probably something that the industry needs to get better at. I'll keep going through these. If you're actually doing excavation, reinstatement, there are some challenges around technologies being expensive, water associated with a leak making it difficult to keep the hole small. That's a key difference between maybe a gas excavation where you haven't got water, you haven't got erosion of the hole. And there are a number around when you're actually doing the excavation activity. So things such as talk about long handled tooling and being able to work from the surface. Well, if your pit's flooded because you're repairing a leak, you might not be able to see the pipe. You might have to keep pumping it out, and that maybe makes that more challenging. There's a lot of things around proving the technology work, overcoming that risk-averse water industry sort of reluctance to adopt new ideas. And something the industry probably needs to get a lot better at is specifying the problem to the supply chain, actually being very specific on the problem we're trying to solve is, so that when the supply chain invests in solutions, it's solving the right problems. And I think the final one was just about the in-pipe activity stuff, so the no-dig stuff, which is really about questions about, so the DWI regulations, Reg 31, trying to move that from being maybe seen as a barrier to innovation to being seen as an enabler. So quite a lot of challenges. A lot of those are relatively sort of high-level ones, but these have all been looked at in some detail as part of the project. So that's great. Identified some technologies, looked at a load of barriers. How do we actually move this forward and try and solve some of these problems? So the project did three things. Therefore, looking forward, developed a functional specification. Based on that functional specification, did a bit of a gap analysis for existing technology, and then a route map which fed into the wider industry sort of direction. So I'm going to talk about each of those in turn very briefly. And again, there's more information within the report. But the first thing we did was produce a functional specification, a relatively short document, only about 6 pages, and looking again through that process from pre-excavation, excavation, the activity, backfilling, etc. And the reason that was needed was because although there were some specifications for certain aspects, it wasn't all in one place, and there were a lot of gaps. So actually, what the industry wasn't providing was something that was easy for water companies to hand out and supply chains to engage with in terms of solving some of these problems. So pulling that together, and some of it's quite basic stuff, just about accuracy around asset location or leak location, or the ability to maintain that accuracy under challenging ground conditions and things like that. So this document relates to existing standards. I think a key thing is that it doesn't, it talks about some of the existing technology, but it doesn't close the door on new innovation. It's really important that this is open. It sets the requirements rather than setting the technology, specific technologies that can solve those. So this is available as part of the report, and this really is a first in this area for the industry in terms of providing that direction. having produced that functional specification, we could do a gap analysis and look at the technologies that we had identified, and we did a global search and made use of SGN as the partner. A lot of the work that Joe Parker had been involved before on the steering group, so we did quite a wide search of available technologies. This picture here is just one of the examples looking at part of the process of mapping out those requirements versus some of the existing technologies. And I think our overall conclusion was that there's quite a lot of gaps when you actually look at this in detail. There are some areas where there is technology that is available and it's just not being used. But there's also a lot of areas where there's technology available, but it doesn't quite meet the requirements. And for that reason is probably probably part of the reason why it's not being used. And that's the red. So we use the sort of red, amber, green. Just picking out some of the highlights, and there's a lot more detail in the report, but things such as, and I'll talk through each of these, the location accuracy requirement. It's not being met, and maybe there are technologies that can potentially meet that, but they are not in a position to be used by the water industry at the minute. So, and that holds back other techniques. If you can't locate the pipe accurately enough to be able to use a coring technique or a core and vac technique, then you revert back to digging a pit with a mini excavator and making it bigger and bigger until you find the pipe. So that's a key one. Ground conditions obviously links to that as well. I mentioned the long handled tooling, and the long handled tools are one part of that, but obviously the gas industry has specific things that it uses those tools for, and it's developed tooling to go with the long handled tools and certain repair clamps and certain technologies. The water industry has different requirements, and that will be needed. The tool alone doesn't solve the problem. You need the whole solution. There is some interesting work looking at patch repair methods. I know these are used a lot outside of the potable water area, but there has been research trying to develop sort of patch repair techniques, and even the gas industry has developed patch repair techniques, although at lower pressure systems. But they're not yet available. But those patch repair techniques offer potential for operation in keyhole type situations. So that's an area where there is the water supply regulations approval is definitely an issue. And then robotics, there's an awful lot of talk about robotics for in-pipe inspection, in-pipe repair. There's probably people on the call who know an awful lot about that. The robots that have been developed for the gas industry are quite specific. Obviously it's a different environment. A lot of them are developed specifically for looking at rehab of joints and things like that. And they aren't directly transferable to the water industry. So we need to be a little bit cautious and need to think a little bit about how, if we develop robots, we need to think potable water in mind from an early stage. So this is actually my final slide, and then I'll hand back to Joe. So this project sort of culminated in a route map, and Jeremy might talk later on about the wider route maps which Upward have developed, and this is really a subset of those route maps, and this identifies along the top we've got 5 areas which relate to the different stages of the process, and a final one about overarching, and we've got 9 potential follow-on projects here and a number of overarching issues. And I'll just talk briefly about them. If I firstly pick up on the right hand side, the overarching issues and outcomes, these are ones that again people will say yes, this applies wider than just minimal excavations, but organisational change is something that needs to be considered in the context of this. A lot of this won't happen without organisational change. Again, skills, training, competency, we are talking about a shift. We are talking about making the industry more attractive to youngsters who probably want to come in and be involved in technology and rather than employing more and more people to dig holes in the road. Incentivizing and changing the engagement with contractors so that they will go out and they will use this sort of be ready to use this sort of technology. I think that's a big barrier at the minute to some of the excavation technology, whether that's core or even whether that's vacuum excavation. It's expensive equipment. Talked about the Regulation 31 improvements. So this is about the water products being suitable for use in potable water, and of course data records. So these are overarching issues that need to be considered in the round. We've got these these 10 projects. I'll briefly talk through those and then come back to go. But under pre-excavation, we identified there's quite a lot of work that's been done around asset tagging and around tagging assets, but it's not business as usual and it's not widely used. And the industry would really benefit from probably understanding, is tagging really a way forward, and is it the solution, and how does it fit in? And if it doesn't, then what are the alternatives? I think there's something there. And that kind of aligns with that first project as well, around how to solve this pipe accuracy problem, because that needs to be solved first. What technologies are available, and how do we get those technologies into vans that are being used on a day-to-day basis and not just in a research type activities setting? Because that's how you change the business, is having people trained to do that. Then around excavation, how do we make coring business as usual? Well, that requires accuracy, that requires availability of equipment, but there's several aspects to how you change that. Solving the wet and flooded excavations issue. So yeah, if it's wet, it's going to be a leak, it's going to be a pit full of water. How do you solve that problem? And then the potential for this robotic roadworks stuff, I think that comes later on. But there is big potential on the back of the off-gem funding through the gas industry, for potentially the water industry to use the Ofwat funding to look at transferring that technology and adapting that technology. Essentially doing exactly what gas industry's done, but with a head start, because they've already spent 5 or 6 years. In terms of the activity on the excavation, long-handled tooling, developing that, and assessing the potential for repair methods. There is some innovation there that needs some investment. Then the backfilling, there is some very specific stuff in Germany. They've been looking a lot at this temporary flowable self-compacting backfill, a lot for narrow trenching, but does that have an application for smaller excavations? And then finally, this in-pipe, no excavation stuff, it's really about building the collaboration in terms of trialing and testing of a lot of the lining techniques. And we know that's a rapidly evolving area. And I think we're going to see a lot of different linings, whether it's spray lining or SIP lining or other techniques, emerging into the water type applications over the next AMP period. And then the final one is about maybe working with some of the academics who are leading the sort of frontier of innovation in robotics, but making sure that their academic ventures are aligned with what the water industry really needs. And so, and even fundamental stuff like they are thinking about the regulations in terms of products in contact with water. So these are the projects that we feel, a number of them, and they may combine, that we feel are the next steps for this work. And as I said at the beginning, we would encourage people, if any of those ring true with you and you think that you could engage with those, speak to Joe, myself, or Jeremy. We're keen to think about how we can move this forward. This is not the end of the project. Joe, back to you.
Great. Well, thank you very much. And Leo did mention that this project was a bit different. And another area of difference is that instead of the project just finishing with the usual UCWER report, and for those who have been asking or who are interested, I'll come to that shortly. But with this project, it's really important that we keep the impetus going, that we keep progressing. First of all, as far as the report goes, I gather from Acquia that should be issued next week. This will be available to members of the public. You don't have to be an Acquia member, i.e. working for a water company. And my understanding is that in line with the new policy of Acquia, there will not be a charge for this report. So I hope people think that's really good news. But we have got some other activities lined up as well. The interesting thing about this project is that it absolutely fitted with what UK STT is trying to do. So we discussed with UK STT how we could work together, and this webinar is very much part of that collaboration. I would also mention that there's a innovation sprint at the Northumbrian Innovation Festival, which runs from the 12th to the 14th of July at Newcastle Racecourse. Thames Water are organising this sprint, which is looking at no-dig repair methods. I see that Claire Gowdy is on the call, and she's organising this sprint, and perhaps that people could, if they're interested, have a look at the Innovation Sprint website. I don't know if Claire could put the link up on the chat so that people can apply to attend that. And then in September, we've planned a face-to-face showcase event. So another time when we're going to meet in person. So Northumbrian, it can be either in person or virtual attendance. September will be face-to-face, and we'll be showcasing where things have got to, technology, looking at innovation, and where appropriate, developing collaborative proposals to submit for funding. So there is real collaboration. It won't stop there. We will continue. So I hope that's reassuring. And now I'll hand over to Jez to talk about all of this in context and what water companies are doing.
Thank you very much, Joe. And let me just start sharing my presentation. And what I want to take you through is just an explanation of the kind of reasons, what's the drivers that are going on here, because there's some huge ones coming through. So in March this year, Water UK published a leakage route map. So what this is doing is effectively saying, okay, this is where leakage needs to be going over the next 30 years. How are we going to drive down leakage? I'm going to put the link in the chat so that everybody can get a copy of that. But it's a really important document because it sets out our plans going forward. So I've gone through those plans and I said, okay, how does that affect us in terms of our research plans and what do we do? And it's quite clear where we need to go with that. So number one is that in order to meet the challenge of driving down leakage, and we're talking about halving leakage over the next 30 years, okay? In order to do that, we've got to collaborate on an unprecedented scale within the UK, okay? So it means joining together all of our research streams, okay? There's some ability to bring in knowledge, innovation from outside the UK, but it is quite limited. And that's because of things like supply pipe leakage, our mains renewal policies, interruptions to supply. These actually limit us on bringing in innovations from outside. And I always get queried on that. So I'm going to explain one as an example, which is interruptions to supply. In the UK, we say we're not allowed to turn the water off for more than 3 hours, and effectively water companies get penalised for that. What that means is anybody that's got, say, something like a semi-structural liner that takes longer than 3 hours to cure is going to really struggle to bring that into the UK. And that's one of the things we're trying to deal with at the moment. And so what we're looking to do is join together the joint research programs. So we've got UCWEAR, we've got the National Innovation Programs, we've got company programs, they're doing innovation as well, and third-party developments. And really what we're looking for is a holistic development plan. So we badge everything in leakage under these 4 areas. Prevent, aware, locate, and mend. The acronym is PALM, okay? And in order to manage leakage, we've got to be good at all of those. And when I started getting involved in the research 4 or 5 years ago, I coined this acronym because I was deeply concerned, like Joe was, that most of the research we see is in the awareness and location. And I really wanted companies to refocus and talk about prevention and talk about mend. And we're starting to see that come through. It's one of the reasons why we commissioned this project. So I did a piece of work just before lockdown. I visited every single water company in the UK. I persuaded the companies to share their research. And I said, tell me what you're working on. And this is what you're seeing as a summary of that. We broke it down into different areas. And the left-hand number, the smaller number, that's the number of projects. The right-hand number is the value of those projects. And I based that upon the ability on how complete the project was, how willing the companies were to share the information that they got, and the size of the project as well. And what that's showing us is that most of the innovation is exactly where we thought it would be, is in terms of that bottom left-hand side there, awareness and location side. And sadly, what we're seeing is that there's very little there on the new leaks are minimized. That's the prevent side. And you can see very, very little innovation taking place in repairs are quick, economic with minimum disruption. So that's really driven this program going forward. So that's the current UCWEAR plan. This is what we're looking at the moment. You can see there's a large number of projects going on in there at the moment, and certainly looking at that repairs are quick, economic with minimum disruption, that 5th column. But as a result of the route map coming out, I'm having to upgrade all this. I'm having to change a lot of these processes and projects. And that's a very quick overview of where I'm looking at the moment, of where we're going to have to take this. And as you can see, it's driving a huge change for us. So in the last few minutes, I'm very, very briefly going to explain some of that. And so what I've done is I've broken it down into 9 themes. I've said we need to understand where the UCWEAR research will go on those. We need to understand where we can use the innovation competition to develop new solutions. We need to see what the water companies are doing, and we need to look at the third party, and that's a large group: regulators, supply chain, academia, consultants. So for each of these areas, I've broken it down and said, okay, what does each of these need to do? And I don't intend to go through all of these areas with you. I'm going to leave this so that you've got those slides so you can actually have a look. But what I want to jump through to is theme 6, innovative repair techniques. Okay, so the leakage innovation heat map highlighted the current lack of innovation. This is what we need to be doing. So you can see there in my UCWEAR, need to look at developing fast tracking methodologies for innovative repairs, investigate and benchmark contract terms and conditions, reduce the time taken, and as the understanding and techniques improve, provide benchmarking and best practice. We're looking at the innovation competition. So this is the Ofwat innovation competition. There are millions of pounds worth of funding there available to the water companies, available soon to third parties as well. And we want to be developing test sites for investigating and trialing repair techniques. And in fact, Northumbria have been really successful in getting a project through on that basis. Develop existing and additional techniques to carry out, and develop techniques for temporary repair. I always say, you know, if you had a cut in your arm and you obviously want to keep the blood in, you do a temporary patch until you can get to hospital. And I'm interested in those kind of technologies and going, you know, where we have a difficult repair, can I do something temporary until I can do a full repair? Water companies we're looking at and saying, okay, can we ensure all water companies utilising the latest repair technologies, trialling the new solutions as they come through? We know that Reg 31 is an issue. We're looking at how we can reduce the time taken for that, and providing benchmarking solutions as well there, so that we can make sure that everybody's using the best ways of doing things. And then finally, from the third party, working with them to understand those Reg 31 approvals and to continue to develop new technologies and techniques. And then, having talked about repair techniques, I would like to also talk a little bit about networks and renewing our network, because, you know, this is UK STT. I know the work that you do, and we're really going to have to be driving our renewal and supply pipe replacement programs. So we've got to come up with ways of laying plastic pipe so it doesn't leak. And we've got to come up with ways of rehabilitating our existing cast iron and other materials that are in the network. That's been a real bugbear, I think it's fair to say, in the UK for many, many years. Our replacement rate is between 0.2 and 0.3% per year on average. That's got to change. It's something I'm working with the regulators on. But as Joe has already said, expect to see in the next AMP a real push to start getting the mains replacement and rehabilitation rates a lot higher in the UK. When you go and read that, the Water UK route map, you will see that there are a number of techniques that companies should be using in order to drive down the leakage. And they start with optimizing your active leakage control. Do you know what? Most companies, pretty much every water company, has pretty much managed that bit. You then talk about pressure reduction, and there's a lot of companies that are really starting to push those down and really doing some clever work in that area. We then start to look at things like smart networks and smart metering, and we've got companies that have already rolled out. My own company have rolled out a smart network across our entire patch. Where does that leave us in terms of leakage tools to drive down leakage? The only one really left to us is going to be mains replacement and mains rehabilitation. So that will become an increasing priority going forward. There we go. I'm going to stop there because I do want to leave us a little time for questions. Joe, back to you.
Hi, I'm not sure whether Tom is going to manage the questions.
Yes, I will. I'll take the screen back and get stuck into the questions and answers. So now it's time for the question and answer session. But to start it off, all I can say is, wow, that was a very quick ride through a big and complex subject. And thanks to all of the speakers for explaining the opportunities and the challenges, particularly the opportunities. I think it became very clear that, you know, this is setting out on a journey and a vision for the future, but massive opportunities for the trenchless industry to become involved with innovation. And innovation and technology in particular isn't an end in itself. It is a way of achieving something. There were a couple of questions on the chat about the reports and the links to them and to the Northumbrian Innovation event have been placed in the chat. I'm very pleased to see also that the Acquia report next week will be available to all of us and for free. There's a couple of questions, but just to kick off, Leo, you talked about blockers, and one of them was mindset, and this: it's too expensive, it's too difficult. I, by chance, read this week about the electricity industry, and in 2012, they got together the good and the great, the world experts on electricity grid network operation, and they studied the subject and came to the conclusion it was absolutely impossible to operate an electricity grid with more than 50% renewables as the sources of the electricity. 10 years later, it's being done on a daily basis in many countries. So this too difficult, too expensive is rubbish. That mindset has to go. And we've got a strong driver. We heard that the water industry has made commitments to be carbon neutral by 2030. In time terms, that's roughly the day after tomorrow. It's not a long way away. And to achieve that, there has to be change, and change brings opportunity. And that really, I think, is what all this is about. We've had the scene set for us of the recognition in the water industry of the need for change and the opportunities that creates. Now we have a couple of questions. I'll go to the Q&A, and they're both from, well, the name is iGaston, which might be Institution of Gas, perhaps. The first two are related. How much further has the gas industry got on the route map? And are they still at the same position despite all the R&D? Perhaps that's one for Leo.
Yeah, I'll try and answer those sort of combined. So yes, the gas industry has had off-gem funding for, and others will probably know better than me, 10 years or so. So they've had 10 years of significant investment, and that's obviously been covering a whole range of challenges the gas industry has, not just around repairs and assets rehab, but that's one of the main focuses. And I think it's important to not come away from today thinking the gas industry has all of the solutions and they've solved the problem. They are ahead of us in the respect of what we've talked about today. Some of the technologies that they've developed, they've worked very effectively with the supply chain from around the world and developed technologies and undertaken proof of concepts. And in terms of the res technology, the robotic excavation stuff, they are now at a
We've lost you temporarily.
No.
No,
Yeah, I think Leo's just dropped off there, Tom.
yeah, his sound has gone.
Yeah. So maybe if we answer one of the other questions.
Let's move on to the next question.
They also have other big problems, such as other big challenges. Hydrogen. Suddenly their innovation program is all about hydrogen because that's what they need to think about. So yes, they have other challenges. But
okay, thank you, Leo. Yeah. We lost you for a bit, but glad you were able to rejoin. That certainly is helpful, and I think it's a fair point. You know, we can look to the gas industry, benefit from what they've done, but understand that they haven't reached the end, the goal yet.
Exactly.
It's a long journey. Next question from Steve Webber. CML, I assume cement mortar lining. What's the time frame for relaxing the 3 hours to say 8 hours to enable lining technologies to be used? Or perhaps the question should be, is there a time frame for doing so?
Yeah, let me take that one. I'd love to say we know exactly what that time frame is. Okay, we don't. I've been lobbying on this for a year or so. We've certainly seen responses from Ofwat now to this, and I had a very good meeting with them about a month and a half ago with them and other regulators where I raised this, and we've got some other meetings coming up with them. I think, you know, it's a little bit of Ofwat did this because they saw it as a customer service measure, and what they didn't realise is the impact that would have upon other areas. I think particularly going into the next AMP, where we know that mains rehabilitation will become an increasing issue with the water companies and also with the National Audit Commission, Infrastructure Commission, who basically have been driving this as well. I'm going to say I'm hoping that there will be movement on that, but I can't promise that, and I will continue to keep lobbying on it. I think it's worthwhile pointing this out from other people, you know, using opportunities to speak to Ofwat and say, look, are you aware, you know, and is there any kind of process that we can do to look at it? I completely agree, though. It's one of those things where you say, would a customer like to be interrupted for under 3 hours once every 2 or 3 years, or do we do it properly and do an 8-hour shutdown and it will last for the next 50?
Yes.
I think the other thing is that Ofwat are looking at the difference between unplanned shutoffs and planned ones. So if a customer is given due warning and can make provision, then it's a very different situation from where they suddenly find there's no water. And I think that the warned breaks to supply would make a huge difference, because that's what customers get in a planned renovation. So I got the impression in a recent meeting with Ofwat that they are considering maybe looking at the two different situations. I don't know if Joseph, you.
No, that's probably about the latest I've got, Joe, as well. But we do have some meetings coming up with them, which hopefully we'll be able to get some movement on as well.
Okay, good. Thank you. So potentially in the next AMP period, something may be different.
It will need to be before the next AMP period, because we would need to be putting it into our plans.
Yeah.
Okay.
And we can't. And we need to have some good, you know, quantitative costs in order to be able to do that. So we will need to know exactly what the plan is, probably certainly within the next year.
Okay, great. I'll move on to a question from James Blanchard. What contract mechanisms can the water companies use to incentivize contractors to deliver the challenge on leakage and replacement?
Do you mind if I take that one again
Yeah.
for the moment, Joe? I know
Go
that
for it,
you've
go for it,
got some thoughts on this
Yeah.
as well, but
Yeah.
it is actually, so that's one of the actual Arcware projects that I'm looking at the moment, is to look at contracts and how we can incentivize leakage repair, leakage repair and location. A lot of companies still run, the kind of fine and fix contracts whereby you're simply paid to locate leaks. My company for years has been running one where we only pay the contractor on a drop in night line. And that really incentivizes contractors to find big leaks fast. And one of the new technologies that we're seeing coming through is the ability to quantify the size of a leak. And that leads to some really interesting scenarios where effectively you could say to a contractor, okay, we will pay you a different rate depending upon the size of a leak. And therefore your contractor suddenly starts to incentivize larger leaks quicker. So there are certainly some contract mechanisms that we're starting to look at. My plan is to actually do an Arcware report that looks across the board and says, okay, where do we take contracts in order to use the latest technologies to take advantage of these new systems coming through? Joe?
Well, I was going to come in on the contract side for mains renewals and installation. And I think in the past, unfortunately, there hasn't always been an encouragement to innovate with the contracts. And now water companies are getting smarter. Contracts tend to be more alliance type contracts with some sort of pay and gain share for efficiencies. And I think as well that contractors will need to differentiate themselves even to get past the initial tender prep stage, so that they need to be consciously thinking about innovation. And there are certainly some contractors that are showing they do want to innovate and they are developing new techniques. Some are better than others, and I think this will become more important to water companies in the future. And as I said, alliances with a pay and gain share, some sort of innovation requirement maybe within the contract will become more common. The other thing is that contractors are now becoming part of collaborative groups that are applying to, for instance, Ofwat for funding. And so, for instance, at the September event, we hope that we'll have a mix of both utilities and contractors, so that consortia can be put together which have both. Because if you don't have both, you get a one-sided view and the innovation isn't as effective as it could be.
Okay, thank you. I want to try and rattle through the remaining questions, and I'm conscious of the time as well. So we may have to leave a deeper discussion for the workshop event at No Dig Live. But let's move on to the question from Steve Crossland. You've mentioned that a more carbon efficient solution is one of the key drivers for minimal excavations. But how are you looking to capture and compare the scale of such sustainability savings? It's a tough one.
Yes, you.
Yeah, so certainly, so that's part of the work that my company is looking at the moment in terms of the kind of relining and replacement. We know that digging up the road, there's huge carbon costs associated with that, which tends to push us down lining, and we know that the costs of lining are a lot cheaper as well. Sustainability is going to be an interesting one. It's effectively, we've got to put the whole thing together in a value statement. And I started doing lining 25 years ago in this industry, and back then we didn't think about carbon, we didn't think about sustainability, we didn't think about all of those things. It's now trying to build cost models that do that, and I think a lot of that we're probably going to have to look outside the UK. Unfortunately, over the last 20 years, we've really lost that expertise within the UK, certainly within the water companies. And I think we will have to look outside to get a better idea of the kind of carbon costs and comparisons to sustainability that goes with that. Joe, you've probably got more experience worldwide than me of that kind of thing. Is that something that you're seeing there?
Certainly, there are some countries that are ahead of us. For instance, I was recently at a water loss conference, an international water loss conference, and Denmark, for instance, have very sophisticated systems for looking at carbon footprint. I would like to give a mention, though, for the Institution of Civil Engineers, who are developing methodologies and accreditations so that low carbon construction methods can be encouraged, and they're doing a lot to push this. So I hope that more will be coming out from them, because we're not the only ones installing pipes, and it makes sense for all the different industries involved in excavation, for instance, or considering backfill or whatever, reinstating roads, highways, that we work together to get a standard approach for each part of any activity.
I'd completely agree, Joe. The only thing I'd add is that I think the industry did look at this 10 years ago, 15 years ago. We were probably a little bit ahead of the curve. Maybe we were thinking about carbon in the early days when some of the rehab techniques were in place, but it's stuff that as an industry, sometimes we forget what we knew. And I think the stuff we could bring back and update relatively easily to do those sort of carbon calculations and benefit assessments.
Good, because it's a very good question in that respect. We're talking in sort of slightly qualitative terms about reducing how we reduce carbon, but it does need to become quantitative because people have made quantitative commitments. Joe's comments led nicely into the last remaining question, which is from Frank Gowdy about vacuum and suction excavation. The industry appears to associate vacuum suction excavation as expensive. Are you only looking at it as a bespoke system for core and vac, or are you looking at the other wider benefits that it brings to the table, such as increased safety, reduced damage, and the typical reduction in excavation size that the technique brings as standard? Historically, the gas industry claimed 50 to 60% reduction in excavation size just by adopting suction excavation when digging down in areas with other buried plant in the vicinity. Who would like to grapple with that one?
I think the answer is yes. It needs to consider all of those benefits. Yeah. Basically, it's not just about core and back as a narrow solution. It's about health and safety, reduced damage, working near trees and things, tree roots and things like that. There's a whole range of different reasons why industry should be very much aligned with what the gas industry is doing. Those benefits haven't been quantified, I don't think, but they should be.
I agree, Leo. I think the slight issue we've got here is that we've been talking very much exclusively about repairs.
Yeah.
Okay. So, a lot of the core and back work that's done is, great stuff on things like metering, where you're just going around, you've got a dry hole. Okay. And as Leo said, when he was going through his presentation, as soon as we're starting to talk about a wet hole, as soon as we're starting to talk about trying to find a leak underground, we are making the situation a lot more complex. In order to be able to do that, you've got to be able to, number one, we've got to be able to locate within certainly centimeters, if not better. And we struggle to do that. Even with modern correlators, we struggle to get that level of location. We still get the occasional dry holes where we're digging down and we're not right on top of it. If you're going to do that kind of excavation, you've got to be very, very accurate. Secondly, we've got a wet excavation. And that's not just how you're actually going to go down into that, but you're going to end up with an egg-shaped hole, because we know that you end that water will have basically eaten away around the pipe, and so you end up with a really difficult excavation and compaction afterwards of putting stuff back in. And then thirdly, you're going to be operating in a really difficult environment to see what's going on. It's not going to be a dry hole where you can look down and find out. It's going to be a muddy hole down there. I'm looking currently at sonar and seeing whether we can get sonar cameras that we can drop down that will give us that kind of sonar pictures and say this is what's actually going on down there, because you can't do it with a conventional camera. You just won't get a good picture. So it is, I am very interested in these kind of, micro excavation techniques. I just recognize that's quite a complex fix to do.
Okay, great. Thank you very much for that. Well, there are no more questions. So all that remains for me is to say thank you to everybody who's attended, but especially to Joe, to Leo, and to Jeremy for imparting so much information and communicating it so well. So thank you. I've learned a great deal. As Joe mentioned, we will at No Dig Live, which is in September at the Peterborough Showground. On the Wednesday, the 14th of September, we'll have I think about a half-day industry workshop expanding on this topic of transferring minimal excavation methods. That's an opportunity for a longer and larger dialogue. I believe all of today's speakers will be there and expanding on what they've told us today. So please, if you have an interest, if you have a technology, then please do come along to that. There was one question somewhere which seems to have disappeared, but it was a very good one. Is there a platform for people to present and propose technologies?
So I answered that one, Tom, already. So I typed in an answer. You'll find it in the answered ones there.
All right, that's why it disappeared off my list. Yes, you're right. Yeah.
So what I actually said is most of the larger water and sewage companies that will have their own innovation platforms on their website. What there is now is a joint approach across the industry, though. So it's called Spring, and I put the link in there. Go and have a look at the Spring site. That is going to be that's coming through now as the joint innovation platform for the water companies.
Great. Well, thank you for that. You're a little bit ahead of me, but yeah, thanks again. Please, further interest, something to contribute, want to participate in the opportunity, it would be great to see you all on the 14th of September in Peterborough. There's a big awards dinner that night as well with the UK STT Awards, so it's a good day to be there, and the No Dig Live is a worthwhile show in its own right. So once again, thanks to everybody, especially to the speakers, and hope to see you at No Dig Live. Bye-bye, everybody.
Thanks.
Thank you.
Bye.
Bye.